Okay. And one of these days I might need to bring in a ringer who's good at the bow and arrow stuff inside of VR. Are you good at the bow and arrow stuff in VR? Yeah. Because man, I've been playing this game and I'm like near like one of the end bosses. And the whole game's been like not that big of a deal. I just can't beat this guy. I spent 45 minutes on him yesterday. I was huffing and puffing at the end. I don't like a lot of work. And you got to shoot these fireballs out of the air, and then you got to shoot the ice ball to stun him, and then you shoot him. And I can handle the ice ball and the shooting him thing. It's the fireballs that end up killing me before the fight's over. And you got to do this. You got to do the cycle twice. You knock off his armor once. And then I got that far, and then you got to do the whole thing again. I only get about halfway through the second time before I die. And it's like infuriating. It'd be way better if I just died early. So I might need to bring somebody in to like beat that part of the game, private. And then they're like, you know, because you have like different difficulty settings for the game. It says, you know, remember in settings, you can set it, you can change your difficulty. I already have it at the easiest. Yeah, it's the real problem is, and maybe this comes down to that argument over inside out tracking versus outside in tracking. I should go down and try that same thing on the VR downstairs with the outside tracking. It's when you go to grab the string on the bow, it misses it sometimes, especially when you're doing it like a whole bunch, and then you start missing, and then you get off, right? You know, it's like you know, when you're playing like old like Guitar Hero or something like that, where you miss like one or two notes, and then you just start missing like a whole bunch in a row. It's the same thing. It's a science thing, I think. Psychology thing, maybe.
Oh yeah, there's like a parse thing where it's similar but different. There's something I know where it's like if you're bad at something, if you do it in front of people you're even worse, and vice versa with it.
I see. Well, at first I was doing it in the living room. My wife was doing a water change on the fish tanks. And then I thought, well, maybe I need to stand up to do this. So I went into the bedroom to do it in there. So, you know, I removed my audience. Probably did a little bit better, which then made it worse. Because I wanted to just give me like a skip button. Because the rest of the fights are so much easier because I don't have to do the work myself. I've just farmed a whole bunch of material to buff up my shark man. I got a shark man that fights for me. I know this game sounds awesome, doesn't it? So I just send him in. I just run around, let the guys chase me while shark man beats him up. That's what I want to do in this part. But I'm in a different form in this part. I don't get shark man's help. I'm unprepared. All right, so for today, we're supposed to do what, if statements? Or well, let's see, we're not actually writing booleans yet, right? We're just assuming zeros or ones for the boolean. So we're creating whatever our mindset is for a for asking questions in our language. So I gave a example of what you might have done. You can write yours however you want, because I mean, this is your language, but you know, I said maybe you're saying ask some question, then do whatever you do if it's true, otherwise do whatever it is if it's false. And I had suggested that it might be nice to make the otherwise optional, like not necessarily require it otherwise. So I'm not sure that necessarily matters, and maybe even in a functional language, the otherwise is almost required unless this is like the last thing you do. in your code, in your whatever function you're writing. All right, so I'll go ahead and implement it like this. All right, so we need to add to our parser. Well, let's give ourselves some sample code here. So we'll just expand inside of our function call. So we'll say ask something like that. Put my parentheses at the right place. And then I need to close my function, right? So we're calling this function on these parameters. This function takes in 2 parameters. I'm going to ask a question. Here's my simplified Boolean expression right now, just 0 or 1. So ask, since it's true, it should execute this part. Otherwise, if I change it to a 0, it would execute this part. Does that look like accurate syntax at this point? Okay. So let's go ahead and add this to our parser first. So we're looking for something whose car is equal to the word ask. So let's see, we'll put it over here. So parse no code, if we're looking at an ask, then what we need to do is we need to turn this into a parsed version of itself. So then what we need to do is we need to decide, well, what does a parsed version of this guy actually look like? Go ahead.
I think you're in the run parse. So
I'm in the run. Oh, thank you. Well, it would have still worked as long as we made our parsed version look the same as. Yeah, there we go. So if that's what we're looking at, then we're going to create a list, and maybe we're going to call this guy we call it an ask expression, a conditional expression, call an ask expression. All right, an ask expression requires multiple pieces, a Boolean expression, a true expression, and a false expression. Okay, so right now our Boolean expression isn't something that we're going to have to parse. It's just a given, right? So we probably want to go ahead and get the car or the cooter of that guy. Catter of no code will get us. Here's my ask. That's the car or the cooter. Get us the right dude. So we'll just toss that in there. Then we want to have our go ahead.
Oh, because the one is in parentheses, you might figure out
It depends. Do you want the one or do you want the parentheses? I mean, you want the one? Okay, that's fine. We could. So the catter gets us the list containing the one. The CAADR will get us just the one. I guess possibly depends on what the thing looks like. Because it would be our Boolean expression inside there. I think it can go either way at this point. So this will grab the number that's inside of that list rather than the list itself, which is fine. Okay, so then we have the true expression. And our true expression is going to be the car of the coulter. This guy, but we need to parse it. So we're going to call no parser. The car of the coulter of no code. And for right now, we'll just say the otherwise is required. So that means the false statement. This is the car of the coulter. This would be the car of the coulter. This would be the car of the coulter. Or we can take the car of the reverse. No, that's the thing, right? So if I take the car of the reverse, that'll get me the last element. Well, I mean, it's not like this other part's hard. It's just got to be meticulous of how many coulters did I need to call. Are you sure? I see. So this is 1 coulter, 2 coulters, 3 coulters, 4 coulters. All right. But we know that we can't do an A and 4 Ds. We decide that function doesn't exist.
I think so.
1, 2, 3. Yeah, not defined. Okay. Oh man, you know what'd been awesome? What? If we since we want to call parse expression on that guy and parse expression on this guy, if we got this list and then mapped parse expression across the list containing the car and the catter, and then appended it to the original thing, it would look awesome.
Why do you want the word otherwise?
Because that's like an else.
Why couldn't you just be like, because the if statement in scheme.
We're not writing scheme, we're writing no code.
I'm just saying.
By definition, it's not a good language. It's a verbose programming language. I mean, you could have written this however you wanted. I mean, as long as you're willing to lose points. You absolutely do not have to write the word otherwise in here. I'm just trying to be very verbose in the difference between our language syntax and then what we're processing. You know, kind of almost purposefully making these guys very different to kind of show that idea of what parsing the code ultimately gives us. All right, well, so since you don't want to do it the cool kid way, or even the less cool kid, but still doesn't get his lunch stolen way, with the reverse thing would have been awesome. Fine. So do we, shut up. Do we see how the reverse works? So we have a function called reverse that just reverses a list. So what we can do here is we can call no parser on, we're going to reverse no code and then call the car on that guy. So reversing no code will end up making this part the first part, because I'm reversing that. I'm looking at an ask. So I'll reverse it. 5 will be the first thing, take the car of that, parse that. Make sense? The alternative is you could take the car of the 4 cooters. They both will accomplish the same thing. All right, but this one's okay. You're good with this? It's not gonna put a damper on things. You sure you don't want to do the map thing? This would be a forced use of map, just to use map. Because you're purposely going out of your way, because we'd have to get rid of this piece. I'd have to build a list out of the car and the catter, and then call map of no code, what parse no code on that. You'll let me use map then? All right, let's keep cooking. Well, we get to learn map. Map's really powerful. You can do a lot of cool stuff with map. All right, so that should be our parsed version of ask expression. And let's see if we get where was it that? I did not finish my. So where is my, here's my ask expression. Here's my boolean. Here's the do math part. And then here is that's the true statement, and here's the false statement. So it looks okay. No, why would we? Yeah, I mean, that's what I was saying about the, making sure that our syntax, what the human being would write, is very different than what the computer needs. The computer can make the assumption that the first part is the Boolean, true expression, false expression. It doesn't need the extra language in there. It's the human being that's really spelling out what they mean. I'm asking a question. Here's the question. This is what I want to do if it's true. Otherwise, I want to do this. Okay, so the human being's writing all that syntax, but once we parse it, we're turning it into kind of a compressed version or a parsed down version to just the actual core components that are necessary. Okay, so now we'll go down to run parse code in here. And we're interested in whether the car of parse no code is, what do they call it, ask expression? Ask expression. So if I'm looking at that, then I want to do some stuff. All right, so what stuff do I want to do? Well, I need to process the Boolean, then decide which of the expressions to run. Not too bad, right? And for right now, our Boolean expression is pretty simple, right? If it's equal to 0, do the otherwise. If it's equal to 1, do the first thing. All right, so we're going to ask if, and we're looking at this piece, that's the car of the cooter. of our parse code. So if, and we can use the equal sign here because we're doing comparison with math, EQ question mark will still work. All right, but we are doing comparisons here with math. So just to drive that point home of the difference, the different equal thingies, we'll go ahead and use the equal sign. So if equal, the car of the cooter parse no code. If that guy is equal to a 1, then what we want to do is we want to call run parsed code on the correct portion of this, which is going to be the car of the cooter. Along with the environment. So if my Boolean expression is equal to 1, call this dude. Otherwise, car of the cooter. And that exists, right? I think the three exists. And that should be it. So in this particular case, in here, I want to bring these 2 lines down by where I'm running it, just so I could reference my code more conveniently. So since it's a 1, I'm going to be doing math stuff on what's A times B is 50. So I get a 50 out of this. All right. And then if I change this to a 0, I should get a 5. What am I calling my run? Run parse code. This should be calling it on that, right? What's going on? Just want to make sure that it was working. Go ahead.
In the blank space, you have parse no code.
Oh, look at the else.
After you define parse no code,
Yeah.
you just have parse no code.
So this is my no parser of sample code. And this is inside of my, so this is my parse variable. So this is my parsed no code. So that should be the parsed version of it, right? Looks good. So now if I call run parsed code on this dude, it should run that parse no code inside of my environment. It's a very strange output. Just before we do anything crazy, let me close Dr. Racket.
We're going to see which lines are actually good. If it's the mapping stuff, it's not gonna-
Okay. Well, the only thing we changed was in our ask expression. So that's our math expression there.
The possibility with the parentheses at that also attached to the-
Which else?
I was thinking of the one at the very bottom where it just says student parse method, because it is hidden that.
Oh, hold on. Yeah, I think you're right, though. If that's true, do this. Else, okay, no, I think we're okay. Else do this. I don't even know how that's even reasonable output. Oh. When did I do that? We must have been debugging something. Oh, that's it. 2 classes ago, after we had a bug at the end of class, I put a big dissertation on Slack saying this is what was wrong. So this was part of the debugging. So in this else, this should be what we're looking at with a call expression, which makes sense because right now our output is this dude. When our original function is the call expression, which kind of makes some sense why it's not showing us the right thing. So if I'm looking at a call expression, then what do I need to do for a call expression? Oh, I could just grab it from everything under the else. All right, so this should give us a 50 right now. Good. So let me put my ask back in. Should still give us a 50. And if I change this to a 0, it should now give us a 5. Okay. So that should give us our working if statement. All right, so questions about that? I think that covers homework for today. All right, so next thing would be is we would really like our Boolean expressions to be a little bit more usable than this. All right, so we have in our current language, we can start building Boolean expressions out of this idea of trues and falses. Well, actually, as of right now, we can build it out of the idea of like math stuff, right? Less than, greater than, those kinds of things. So that's probably the thing that's the most compatible with the current version of our language is adding a Boolean expression to our language that allows us to determine a true or false. All right, and then we could support the normal arithmetic Boolean operators, less than, greater than or equal to, less than or equal to, yada, yada, yada. The next thing, though, we'll have to think about is, well, what about our logical Boolean operators? So ands and ors, things like that, things that allow us to build out more complex Boolean expressions. So the question here is what does a Boolean expression look like? When we build a Boolean expression in our language, this is not the right. Lost something. Something went flying away. All right, so Boolean expressions. We need to have a parsed version, an unparsed version of a Boolean expression. So maybe something like bool less than 5.7, something like that. All right, so this guy tells me that I'm going to be boiling down to a Boolean. All right, and then this is the actual stuff that we're going to be doing. Let's just think ahead a little bit, though, so we can certainly replace this stuff with, you know, all the less than, greater than, equal to, things like that. What about ands and ors? So we can have a bool that has an and that has a bool less than 5.7 and another bool greater than 2.5, something like that. And this whole thing would boil down to a Boolean false in this case. This is true. This is false. We're applying our and function to that guy, which should give us a false, which is a Boolean, the output of a Boolean. All right, this allows us, now we could say, well, why not just put something like, go back to our code here. Why shouldn't I just put something in here like less than 5.7? What's the downside of doing that as opposed to something like that? Go ahead. No, we can make it work the same way. Okay, tell me more about that. So let's look at our language reference. Let's go ahead and add our ask question to this guy. And then hopefully this takes us down that path. So we're going to say ask. And then right now it looks like this, right? Then we have our no lang expression, otherwise no lang expression. So that's our syntax for an ask right now. And really what we want to do is we want to upgrade this guy to have a more powerful, more usable thing in there. If I decide, okay, well, I want to be able to ask, do things like arithmetic. Let's see. I'm going to have a bool. Arithmetic. Bool op. No lang expression. No lang expression. Now I flag this guy as a Boolean. I could then put in here, as of right now, I could put this. I can say, oh, ask, and this can be any no lang expression. But is that reasonable? Don't we want our interpreter to kind of keep us in line relatively reasonably? What this really says here is I can put anything. My language reference is informing me that I can put anything I want in those parentheses. Now we know that we expect it to be the form of our language that follows this dude here. We really need it to be that guy. Because if I throw it just a number or a function or any one of these other productions of my grammar, it's not going to work out very well. And we've already done a little bit of this in our language, but at some point we need to kind of, pump the brakes and say, okay, is this the direction this really should be going, right? Ideally, and if you think back to when you first learned about like, in 200, when we talk about what's a Boolean expression, any expression that boils down to a single value of true or false, when we introduced like if statements, we specifically said it's the word if followed by a Boolean expression, not just any old expression, but very specifically a Boolean expression. Okay. So the question here is don't we actually now have a new language of Boolean expressions? A secondary grammar that is the grammar of Boolean expressions. Where we could say a Boolean expression is one of these productions. So now we do need to think about this in terms of our parser and interpreter that we already have. We're still going to need to be able to somehow differentiate a Boolean expression from a no code, generic no code expression. Those need to be differentiatable. Otherwise, we would only have the ability to handle it inside the else. And right now the else is already being taken up for our call expressions, right? Keeping in mind that our call expression follows the same, we have the same kind of problem inside of our call expression. In our call expression, we absolutely expect the first the catter, the thing that comes after the call, we absolutely expect that guy to be a very specific production of our no code language. Not just any no code expression. It has to be a function because that's what call does. Call applies a function to some parameters, some inputs. Those inputs can be any kind of no call expression, except which no call expression, or which no code expression would not make sense for our parameters. No call expression could work. This call expression ultimately boils down to a value. This guy here, he could be a call expression as long as he boiled down to a value. parameters need to boil down to a value. So which production of our no code can't be used here? And we can answer that question using this slide too. This slide. Which of these productions here can't go right there? This is still our old syntax that we were assuming exactly one input for call instead of 0 or more inputs. But if we just use this is enough to answer the question. In a call, we absolutely expect this to be our function expression, right? This can be any no code expression except what? Except the function expression. Because function expressions don't boil down to values. Function expressions are data representations of something that we intend to do, but it can't do the work on its own. It only does its work in the context of a call expression. So based on this thing we're talking about right now about creating a secondary language, a language of Boolean expressions, we should have the same thing hold true for a language of functions, function expressions. In this particular case, we would say, well, all of our functions look exactly this way. So it's a boring language. It's a language, it's a grammar that has only one production, right? But if we had, let me upgrade this guy. A little asterisk after that guy, 0 or more of those dudes. If we want to upgrade this so that this guy dictates what this is, I'm going to go ahead and create a no code function expression. Ref. So no code function expression only has one production. That's that guy. Now we might say, okay, well, if it only has one production, why did we do it? We did it so that we can formally say this. A call, the first parameter is a no code function expression. It has to be one of those guys. So now our language further protects us from going off the rails. Because before we were advertising that, hey, you could put any old no language expression in there. Didn't matter which one, but that wasn't true. We were operating under this reality that, hey, you know, it's really got to be a very specific one. And we're just going to assume that you gave us some good code. And because if you didn't, it's just going to break is what's going to happen. It's not going to work. All right. So now we have a updated language of this no code function expression language. Now, when we have a language, we then need to have a parser. And we also need to have an interpreter. Can a no code function expression, can this guy ever be interpreted in and of himself? So we're amending a previous reality that every language needs to have an interpreter. We will never intend to run this code directly. This code is only going to be run in the context of something else. We still need to parse it, right? We still need to put it into a format that is usable. But this guy still describes what that animal must be. So it formally tells us that a call that guy must look like this. And that's really better, isn't it? It might seem like, okay, well now, we have more than one language. That's a problem. Well, we've really just relocated stuff. So let's go and update our code to do this. We're going to be able to steal most of the stuff we've already done, right? We're just going to be pulling one of our productions out of our parser for no code and putting it into a brand new parser for our no code function expressions. So right now we have our no parser. I'm going to put a little comment here. As we maybe see the writing on the wall that we're going to be going down some sort of path where we might have a couple of parsers going on in here. Maybe we kind of define a section of our code for parsers. So we're going to define our no code function parser to be a lambda that'll take in a no code function. And really, we don't even need to have a conditional, because these guys only come in one form, right? They only exist in one possible way. And that possible way, where is my function? This guy. That's this guy right here. That's the only possible production for a function. I don't have to ask any questions like, hey, is your first word function? If I'm in this code, it is. All right. So this guy's going to take in a no code function. And what I'm going to do is I'm going to build a parsed version of that function. It's going to have func expression followed by my list of params, followed by, followed by the word list params. Followed by my, let's see, hold on, where do those params come from? Make sure I don't. Oh, we labeled it in our, okay, got it. So list params, then these are the actual parameters in the body. And then we called our no parser on the body of this guy, which is no code, right? It's not another function. This is of a different language type. Back to our no parser. Yep. This is the parameter that was passed in here. All right, so there's our no code function parser. Which means that in our no parser, we'll never have a section that starts with a function. This guy right here gets removed because that's no longer legal no code. That's a no code function. All right. But now when we have a call expression, what we're doing right now is we're calling our no parser on the catter of that guy, but that's no longer what we do. Now we're calling our no code function parser on that dude. All the logic has remained the same. We've just moved stuff around so that the reference for our language can more accurately describe the rules of our language. A call function requires the first parameter to be a function. We did not have a way of explicitly saying which production of no code it must be. So instead, we've created a second language of functions that has one production in it and said, it's got to be one of those guys. That's what it has to be. Okay. So with those changes, this guy is now true. That a call expression must have a function as the first parameter. Make sense? All right, let's make sure we didn't break anything. So that's in our parser. So now in our run parsed code, we really should have an interpreter for our functions then if we intend to run a function. Because what we're doing here is when we're saying run parse code, the presumption is that what we're looking at here is parse no code. When at this point right now, we actually don't have it does not exist parse no code whose car is a function. That's a different animal. Here's our interpreters. We'll go ahead and define a run parsed function code. That'll be a lambda that takes in a parsed no code function. And you should also take in an environment because we are dealing with environment passing interpreters here. So he's going to take in our parse no code and our function environment. We already know the kind of animal he is. We don't have to ask any questions. If we're running a function code, we don't need a cond. we know that this dude looks like this. And what do we do with it? We run that code. Through our run parsed code, but we're running the body of that code. Does that make sense? This is what it means to execute a function. It means run the body of that function with the current environment. So down here in our run code, we can remove our func expression because that's no longer legal no code. But now when we get into the X, or the else rather, when we run our parse code, we're calling run parse code on this function. That's no longer what we're actually calling. We're actually calling run parsed function code. So this guy here is run parsed function code on the function portion, along with an extended environment. This is our environment that has the new bindings for the parameters that were passed in. All right, so logic hasn't changed. We're just now calling run parsed function code on this function with this expression, which then comes up here and it takes in that function with this environment. When I said expression a second ago, I meant environment. And what do I do with that? I call run parse code with that function. So actually that function is this dude right here. So we're already piecing that out, right? No, this is the body. I passed it the entire function. I'm just saying run the body of that function in this environment. So this is correct as written. So it might seem like an indirect way of accomplishing the same thing we did before. I'm just saying that, hey, look, our function interpreter runs functions. Our no code interpreter runs no code. And yes, some no code expressions contain function expressions, and I pass them to the guy who's in charge of them, who very quickly passes them right back to me. But at least it went through that clearinghouse of saying, ah, I'm in charge of this kind of animal. Okay. Right now, this guy should, well, we don't have those guys yet. So this should give me a 5 still. Oh no, this is my, well, no. Yeah, it should not give me a 5. It should give me the 50 because this is true. So it's doing this. If I make this a 0, it'll give me the 5. Okay, there we go. All right, so does it make sense what we just did? I know it seems like we did a whole lot of things, but we actually did not rewrite one line of logic. We just organized it better. That allowed us to make this thing right here true. That's specifically a call no code statement requires a no code function expression, which we then had to go and invent. And inventing it meant we had to have a parser and an interpreter for running a function. And that's what we did. So now our language is more self-policing. All right, questions about that stuff? Go ahead.
We did something similar to this when we did the math stuff, and the first part of the math expression has to be like the math expression. Is that what that?
Yep.
Why didn't we write it out the boolean?
Well, that's a good question. Let's look at.
I don't want to do it.
No. If we should do it, we're going to do it. But here's the thing. So here's our do mathy stuff. The question is does this guy, is he usable anyplace else? For instance, if I have a we haven't invented this guy yet. That was part of my example. So if we ask this question here, so we're asking a no language expression right now. This is something that we see the writing on the wall. We're going to be updating that, right? Okay, so let that slide for right now. Can this be a mathy expression? A do mathy expression? Is that a legal thing to be put here? Could it also be a number? Could it also be an identifier? All right. Could it also be a call? So the question then is does do mathy stuff, does he belong to the category of no language expressions? Maybe the flip way of asking it is, can you give me an example of an expression where the only possible portion of it must be a do mathy expression? So then that would be kind of our litmus test for whether or not we should make our own language out of it. Go ahead.
So in no language expression is now anything other than a no function expression?
No. Say that one more time.
So a no language expression is now anything other than a no function expression?
In our current world, yeah. But very quickly, it's going to be also anything other than that or a Boolean expression. And then you can imagine that that might continue to unfold, right? All right, so he was asking, does this guy belong in his own language, the do mathy stuff? And at least as of our current understanding, the answer is no, because he is one of the no language choices that can be used in all sorts of places where we say no language expression. All right. So let me give you some updated. Functions to a new language. Are the only option. Call expressions. All right, so now we have to go back and think about Boolean expressions. Just like we did the litmus test a second ago, if we're looking at an ask, what must go in there? A very specific thing, not just any old lang expression. Now, in our current implementation of the ask, we were able to say, like, oh, well, we're just going to assume it's either a 0 or 1. So it's a hard-coded value, just roll with it, right? You know, that's what our current implementation says. But very quickly, as we're trying to make this guy behave more and more like a modern language, we're saying, you know what? Boolean expressions, pretty important. We kind of talked about it like week 2 or week 3 of CSC470. We probably need to have them in our language. And we fast forward a little bit, we can think about, okay, well, you know, conditionals need to have that, loops need to have that. Those Boolean expressions are very specific animals that do need to exist in a couple of different places, but they are their own kind of thing. Make sense? All right, so we need to now think about the grammar of Boolean expressions. So we're saying a Boolean expression is any expression that boils down to a single value of true or false. All right, so we get to decide what our pause on the obvious, true and false. Because if we go back and we think about you know, a language like Java, and I say a Boolean expression is any expression that boils down to a single value of true or false. My question is this a Boolean expression? Is that also a Boolean expression? But I'm not using less thans or greater thans or ands or ors or any of those things. How could it possibly be a Boolean expression? It fits the requirement, right? You know, it says it's any expression that boils down to a single value of true or false. Just because the way I got here didn't require any calculations doesn't make it any less true that that guy is a single value of true or false. I just didn't have to work for it. Okay. The issue here for us right now, and I'm saying let's pause on this, is true and false assumes the existence of Boolean literals in our language, when we actually don't have that yet. Because that starts taking this down the path of, well, now I need to put types into my language. Because right now, I have this idea of having just a number, where a number is, well, a number, right? And then I have just an identifier, which is a variable. But what am I missing here if we're kind of comparing this to a language like Java? We have Booleans. What are my other literal types, non-numeric literal types? Could have strings, okay? Then we start crossing that border between primitive types and object types, right? Where most of our languages, strings are definitely implemented as object types, but depending on the language, are sometimes, at least partially, sometimes fully treated as primitive types. So let's throw strings to the side for a second. Not a wrong answer. Let's just call it, for right now, a problematic answer. So what are other primitive type literals we can have? Characters. All right. Now, we don't necessarily have a use for characters in our language yet, since right now we're kind of a language of numbers, but pretty quickly here, we're going to maybe come up with a use for characters. And it certainly seems reasonable that our language should support characters, right? I mean, that seems like if you learned a new programming language and it didn't support chars, that's kind of an oversight. So something went south there where it probably should have supported that. All right. But Booleans, the idea of a Boolean type, just like we have a numeric type here, the idea of a Boolean type is something that our language really can't exist without. Does that make sense? So we do need to have the idea of a Boolean literal eventually. For right now, we could just say that's a trick for another day. So when we're thinking about our grammar of Boolean expressions, what we really want to think about here is maybe our obvious Boolean expressions. So let's think about our grammar of Boolean expressions, where we have either a numeric expression, or we have a, actually, I usually call these arithmetic, right? Or we have a logical boolean expression. One of those two forms. And our arithmetic ones, I'll just put one production in here, but your homework is going to be to implement just the arithmetic versions of these and update our ask expressions. But an example here might be less than some kind of no language expression, some other kind of no language expression. Greater than or equal to, less than or equal to, not equal to, equal to. Make sense? So homework is to implement these guys. Parser and interpreter, and expand ask expressions to support these. Make sense? All right, but just the arithmetic ones. And you're not adding the types. Shouldn't be too bad, but kind of makes you swim in this new pool we just created with a couple of different interpreters floating around. All right, questions, comments, concerns, bribes? Go ahead.
So are we having it return one or not?
You can decide what you want, because I mean, it never actually is returning something. It's just going to adjust how you implement your ask. I would say it's probably going to be a true or false instead of equal to 0 or 1, but
I have a scheduling question.
Sure.
So two of the classes that I'm taking next semester are at the same time.
450 and 417.
Yep. And I talked to Walker about it. He said he's fine if I take 417 all online at a different time.
Okay.